Hello everyone, welcome to our channel Jinko Academy. Today we are here to discuss about our another project in our series of videos where we discuss the case studies of our project. The project we are going to discuss here today is about another of our product which is used for commercial and industrial applications, which is we call Sangiga. This project is actually located in Japan, and the total capacity, installed capacity of this project is 891 kilowatt charge discharge active power and 15,480 kilowatt hour energy storage capacity. This capacity is for the overall project. This is not for a single site. This project has multiple sites, and this capacity is actually the overall capacity of the project. For the single site, we will discuss later what is the capacity and how and the configuration and application of a single site. The overview of a single site, that this whole site, this project is actually located in Japan, in Kyushu. It's a name of the city. This project has totally have 18 sites. Each of the site is 49.5 kilowatt, 860 kilowatt hour. Each of the site have this capacity. We provide total 72 units of 215 kilowatt hour DC block, which is Sangiga, which we call Sangiga. The project is actually a PV plus ESS solution. The PV panels and the ESS, the whole system was provided by Jinko, but we are here will not discuss about the PV side, about the configuration of the PV panels and about the specification of the PV panels. We will only discuss about the ESS part. The ESS part has 72 units of Sangiga and 18 PCS and DC-DC. Since this project is a DC coupled on-grid solution, so in this project we also have DC-DC, which is MPPT. We can also call MPPTs, and our ESS storage system with a PCS and DC block, which is battery units, battery cabinets. I can tell you this as you can see, this is what the a picture from one of the sites of these projects. As you can see here, these four are actually the DC block. These are the Sangiga DC block units, the 4 units, and behind that you can see there's a container. This container include the PCS and the DC-DC all together in a single container, which are connected to the PV panels, and then eventually they all can get connected to the grid to supply power to the grid. As you can see here, this is a layout diagram of the same project, of the same site of single site. As you can see here, there are 4 units of Sangiga, the DC block, which are connected to the DC-DC and the PCS. You can see there are 5 DC-DC because the DC-DC is not a single unit. It's a cabinet which have 5 different DC-DC units, which each of the DC-DC unit is 50 kilowatt, which are connected to the PV, and then PV connected to the Sangiga, our DC block, then connect to the PCS, and then supplying power to the grid. The main application of this project is to supply power to the grid, to sell power that we generate from the sun, from the solar storage, from the solar panels that we supply to the grid and sell to the grid. We will discuss this about later, about the applications. This solution that we provide, each of these site of this project has 289 kilowatt PV panel modules. Each site has 289 kilowatt PV modules, which are connected in different strings, which we are not discussing here. There are 4 sets of Sangiga. Sangiga is our DC block. Each of these DC block is 215 kilowatt hour, so its total is 860. Once there is one set of 62.6 kilowatt PCS. We also have connected a PCS, which the capacity of the PCS, each of this PCS is 62.6 kilowatt PCS. But for this site, according to the configuration of the site, we have downsized the PCS. We have limited the capacity of the PCS to 49.5 kilowatt. And then there are 5 sets of DC-DC modules. It's a single cabinet, which one cabinet have 5 DC-DC modules, and each DC-DC module is 50 kilowatt. The DC block, as if you have seen our videos earlier, we have discussed about the Sangiga, our product. The Sangiga is the battery cabinet, which have the lithium batteries, which have the BMS, and which have the high voltage box and the liquid cooling system and the fire suppression system. This all include in a single cabinet, which we call here DC block. Discussing about the operational logic of this project, the main purpose of this project is to supply power from the PV panels to the grid, and then we also have connected the ESS system with these PV panels, with this PV system, so that when the PV power is not sufficient, when the PV is not available, the energy that was stored in the batteries, it can be sold to the can be sent to the grid. So what is the whole scenario is there? The PV panels are there. They are connected to the grid, to the battery system through the ESS system. When the PV power is enough, when it's high, it keeps supplying power to the grid and also charge the batteries. And in the time when the PV power is not sufficient, the batteries will supply power to the grid. And when the PV is not available, the batteries keep supplying power to the grid. And when this totally the battery exhaust, the grid will keep supplying to the load to the other side, and the next day when the PV power is sufficient, it will again start charging the batteries and supplying to the load, and this keep cycle is going on like this. You can see here, this is our cloud system. All our projects are connected to the Jinko cloud, where the real-time monitoring of the system can be done. We can see how much power is being generated, how much power is being used, how much power is being generated from the PV side, how much is being charged to the batteries, how much is being supplied to the load. This all monitoring of the system can be done using our Jinko cloud. This is one of a picture taken from our Jinko cloud system. This project, we have done this project as I already said before. This is a DC coupled solution. It's an on-grid DC coupled solution. So why this solution is better for the customer? What were the benefits of this solution? The first benefit is this solution is more high efficient. Why it is more high efficient? Because we are using a DC coupled solution. Unlike AC coupled solution, where we have to connect PV inverters, and then we connect to the PV panels to the PV inverters, then they connect supply to the grid, and then there are also batteries connected to the same grid, and then we have to charge the batteries, and when we charge and discharge charge the batteries, and this power conversion has to be done like from DC to AC. Then for charging, it has converted to AC into DC. Then this conversion is not as efficient as a DC coupled solution. So this solution is more efficient because we don't have this conversion losses. We have the DC coupled solution, so it's more efficient. The second is cost saving. As you might know that PV inverters are more costly. In this solution, we have not connected any PV inverter. It's not an AC coupled solution, it's a DC coupled solution. And for the DC-DC converters are comparatively more cheaper than the PV inverters. So it's quite a cost saving solution where we don't have to rely on the PV inverters, which are more costly compared to the DC-DC converters. This kind of system is more flexible. How it is more flexible? Let me go here. As you can see here, the PV panels are connected to the DC-DC. They're connected to the batteries. Then they're supplying power to the grid. So it's more flexible. If in future the customer, if you want to add more PV panels, it's very easy to add more PV panels to the existing system. They just have to connect more DC-DCs, the PV panels, and then connect to the same. It can just keep supplying to the same site. If you want to connect more storage, we can connect more storage anytime, and then we can keep going on with the system. So in future, if we need to connect more PV panels, if we need to connect more storage, this kind of system is more flexible and it's very easy to integrate for the future use. Okay, let me go back again to this same site. And the same thing is easy to maintenance, as the system has different components. If something wrong with, as you can see in the DC-DC side, there are 5 DC-DC converters modules used in one DC-DC side. If one string have a problem, we can just totally disconnect it, and the 4 can be used. If one DC-DC have problem, this can be disconnected and the other can be used. Similarly with the batteries, the storage, if any of these our Sangiga, which are our DC block, our battery containers, if any of these have problem, we can easily disconnect it and the other system will keep going on, keep working, and it will not affect the overall operation of the system. So this kind of system is very easy to maintain for the maintenance. If one part has to be maintained or it has some problem, it has any fault, it's very flexible for the maintenance also. Not just for the configuration, for the future use, also for the maintenance is very flexible. So these were all the benefits that we get from this system, from the whole overall this project. This is this is from the same project. As you can see, this DC-DC, this is our battery, our PCS and DC-DC container, and our batteries all connected, and all this together. Thank you.